Okay, so is there any problem up to this point of time? So far so good, huh? Okay, so this is now now we want to do some more sophisticated simulation. Okay, so in order to do that, I'm giving you a code. Okay, the code is here. It's in back to RStudio, back to the file, and then there's R code called simulate 11b.r. You see that? Okay. Okay. So now open this this 11br. Okay. Now, as you can see that here are okay, in order to give you a better idea about this process, right? Remember that we are using data to make model. We use model to do prediction, and then we make some assumption, and then we do simulation, and based on the result of simulation, we will make decision, and we will take action, right? So actually, it's a quite lengthy. It's a quite lengthy process, quite lengthy practice, right? Okay. So say it again. This process is quite lengthy, right? From data to model to prediction, and then we make assumption and do simulation, and then make decision and take action, right? The entire thing is quite, as I write here, right? As you can see here, data, model, prediction, assumption, simulation, decision, action. So the purpose of today's course is to give you a holistic idea about what's going on of each of these steps. Okay, so to do that, to better doing that, I give you a code simulation 11b.r. Okay, so go back to RStudio, go back to the file folder, file tab, and then open the simulation 11br. Okay, and in this things you will see you can see the code. So you select the code and press run. Okay, press run. Then you should see something like this in your right hand side. Anyone get here? Get it? Okay? Anyone has problem doing that? Okay. So what's wrong? Maybe you can go to TA and let the TA help you. Okay. So you should see this, right? Anyone cannot see this? Raise your hand. Okay. So you are here, right? Okay, you are here. Okay. So but this simulator is something like this. It's basically everything is the same, except that there's a gear here, right? And if you press the gear, you can actually see this is the payoff metric, right? So you can adjust the payoff metrics as you wish. Okay. So when we do simulation, not only that we can scan all of the possible strategy, and also we can change our assumption on the fly. Okay, okay. But before we change you can press here so that that's to get this. Let's use the let's do some practice first. Okay, using this default setting. Okay, let's don't change the. Let's do not change the payoff matrix. Just use the default setting. Okay, so I would like to do some practice first. Okay. Now the first thing is here is the practice. Okay, we run it, and so first of all we want to know what is the optimum threshold, what is the corresponding expected outcome. Anyone? Raise your hand. Actually, the answer is already here on the top of the chart. Right? See? Okay? So, anyone? What is the expected, what is the threshold, the optimum threshold? Say it, say it loud. Say it loud. Don't be shy.
182.
No. The threshold.
0.27.
Yeah, it's 0.27, which means that in order to get the maximum expected payoff, we need to take action on which kind of people? On the people, on the patient whose predicted probability is higher than 0.27, right? So every patient, after we throw in the data to the model, right? Every patient will get a predicted probability of poor care, isn't it, right? And according to this setting, according to this simulation, we find out that in order to get the best result, we actually should take action on those patients whose probability of poor care is higher than 0.27. Okay? And if we do that, then this is the expected result would be 183, right? Minus 183, okay? Okay? So this is the optimum threshold and maximum expected payoff, okay? I'm always saying expected payoff because payoff would not exactly be the same as this one when you do that. But this is the expected value, right? Okay. So now the second question, okay? What are the threshold and outcome if we do nothing? Okay? In this chart. So the question is, what is the threshold if we do nothing? Okay. If we do nothing, it means all of the points are no action. Okay? So what is the threshold that will lead to no action at all? Sorry? Zero? Is that right? Because if you set the threshold at 0, it means that all of the points will be treated as positive, right? So set the threshold at 0 would end up take action on everyone, right? Right. Okay? So if we set the threshold at 1, right, then all of the patients, okay, because the probability is always lower than 1, right? So everyone will be treated as negative, which is no action, isn't it? Right? So if we do not take action at all, what is the expected payoff?
250.
Yeah, it's minus 250, right? Okay? So if we do not take action at all, okay, this the model will do you no good at all, okay? You do the model, you do the prediction, you do a lot of analysis, but you do not take action. If you do not take action, then the model will not help you, okay? That is a very important thing we need to learn, okay? So if we set the threshold here, then every point will be treated as negative, which is no action, okay? When you take no action at all, actually that diabetic complication will cost you a lot of money, okay? And take some action would actually help you, okay? Now, the next question is, what are the threshold and outcome if we take action to everyone? Which you already answered, right? Okay? If we set the threshold to 0, okay? Which means we take action on everyone, okay? Then the expected payoff is like about minus 200, right? Okay? So which one is better? Doing to all or doing to no one? Doing to all is better, right? In this setting, right? Doing to everyone is better, right? But if we optionally only take the action on the people who is higher than 0.27, right? It is actually better than doing nothing and all in, okay? Right? Isn't it? Right? So that is the point of business analytics, right? Okay. When you are using data to data analysis to make your decision, okay? Your decision is no longer just do it or not do it, okay? It's not just simply to be or not to be, okay? You have a selective action, isn't it, right? The reason that we want to build a model to predict the poor care probability for everyone is that now we know which people we want to take action and which people we do not take action, okay? So when you set the threshold at 0.27, only part of the patient will apply action, right? And that would lead to a better result than doing nothing or doing everything, isn't it, right? So the model will help you select, right? Okay? It helps you identify which one you should take action, which one you do not, isn't it? That is the spirit of doing model and doing prediction for every individual, right? So nowadays, when we have computer, when we have, we can do this simulation, this analytic can help you select the subject that you want to take action, right? For a better result. And it can actually help you find the optimal threshold to take action. and you can actually evaluate the expected payoff if you take action on this selective group of patients. Get the point? Okay? So that is the spirit of doing simulation. Now, let's do some more practice, right? Click the gear and it will pop up, right? Okay. So usually we do not change the no action, and this is good care and no action, right? So assume that is 0, and the risk is poor care, no action. This is good care, no action, right? Okay? Good care and no action, so nothing, right? This is poor care, no action. Then you are very high complication, risk of complication, right? So, and say that, basically we don't want to change these two things, right? Okay? We can change cost, which is the action cost, right? Or treatment, right? Okay? So, if we, now with this current setting, the cost is like 10, right? 10 per person, actually. If the cost increased, right? And as you can see that, is it possible? Or try to adjust the this slide, to use this slide bar to change the cost. Okay. Can you see some situation? Can you see the situation that doing to everyone is worse than doing nothing? In this case, in this default setting, the doing nothing is worse than doing everything, doing for everyone, right? Okay. So if I adjust the cost, can you simulate a case that doing for everyone is worse than doing nothing? Okay, just all in. Right now, all in is actually like better than doing nothing, right? So I want you to adjust the slide bar, okay, to simulate a situation where this point is lower than this point, which implies that doing to everyone is worse than doing nothing. Okay? Try to adjust the bar, right? Okay. And can you simulate the situation that this anyone get the point? So you can do two way, right? This is reduced cost, right? And this is increased cost. Okay, right? When you increase the cost, say what will happen? You can see that when you increase the cost, this is dropped down, right? Isn't it? Right? Okay. When the cost of action is higher, right, then it is like doing to everyone is no longer is worse, right? Because you have a lot of cost, right? If I increase the cost to 20, what will happen? You will see that actually doing to everyone is worse than doing nothing, right? Okay? So it actually depends on cost, right? See? And when I raise the cost, you can see that even the cost is like $20, okay? It's raised from $10 to $20, okay? Still, if I selectively use this tool, okay, I can still reduce the cost from 250 to 193, isn't it? Okay. So if the action is more costly, right? You will do less people, because when it's $10, the ratio is 0.27, right? So more people are taking action. But if the cost is like 20, then you only do the action to law school. The predicted probability is higher than 0.36. Okay, isn't it? Okay. So this is the effect of cost, right? Okay. So this is the effect of cost. Then now we can also do something on the effect, right? The effect. So originally I believe the default setting is like okay, the default setting is minus 50, right? So this is actually reduced risk plus cost, right? So if this action is more effective, right? It's more effective, then we can reduce costs lower, right? Okay? And if it is less effective, then it will go this way, right? So if it's less effective, then as you can see that from 50 to 60, right? So it can only reduce the cost from 100 to 50, right? Plus the action cost 10, right? So now as you can see that if it's less effective, there are two phenomena will happen, right? The first thing is this side will slide down, right? Okay? And the second thing is that the threshold would move to the right, isn't it? Right? Which means that because it's less effective, right? So you tend to take the action on less people, isn't it? Right? And if it become more effective, say down to 50, then you'll see that we'll do it on more people, right? And this is higher. And if it is even more effective, like 40, and you can see that we will do more people, and this is actually higher, right? See, it raised from like originally 200 to like here's about 175, isn't it? Right? Okay. Okay. So this is the way that we do a simulation. Not only that we can scan all of the cutoff, but also we will reserve some with R programming, right? In this code, actually this code is the same as what we previously used, except that I'm calling this manipulation function, and I just put the matrix into slide bar, so we can change the payoff matrix on the fly and see the effect on your strategy. Okay? You see that? So this is one step forward, right? Okay. Not only that, we don't need to write a program for every different payoff metric, right? Because every business context will lead to a different payoff metric, right? So when the payoff metrics change, right, you actually can use R programming. In the R environment, you can actually have flexible assumption. Okay, this is why we introduce flexible assumption. Okay. Now there's a practice, and I would like you to the last practice that I want to do today is that now if we have a series of actions, it's not one action. You actually have, for example, you have like 5 types of drugs, 5 types of new drugs that would be helpful for the poor care people, right? And the cost is like $5, $10, $15, $20, and $35. Okay, and it can reduce the risk from 100. If I use the $5 action, I would reduce it from 100 to 70. If I use the $10 action, I can reduce the risk from 100 to 60. Okay? So I have 5 types of action and cost, and then their effects are different. Okay? So I want you to like this is a team action, okay? So I want you to use this simulator. You don't need to write program, right? You just as I say, you don't need to change these 2 things. Only these 2 slides need to be changed, okay? For example, if I want to evaluate the $5 and 70, okay? I should change here to like $5. Okay, it's $5. Okay, and because it reduced the cost to 70, right? Okay, you should change it to 75, right? 70 and plus the cost of action, right? Okay, so this slide bar is a little bit tricky, right? You need to add this number with this number, okay? So this is the simulation result for the first drug, okay? Now I want you to write down, right? This is the first option, right? And and you should write down the just write it down, right? Okay. And then you can change to the second drop, which is I believe it's $10, and it will reduce to 60, right? And plus this $10, it will reduce 20. Now this is the second action, okay? So every now we have 5 cases, right? And every case will have its own payoff metric, isn't it? Right? You can adjust this one and this one to reflect these 5 cases. Okay? And so if you have these 5 drops, what are the optimal ratio and expected payoff respectively? Okay? So you can write down 5 the corresponding thing. So which action are the best expected payoff? Right? So if you have 5 drugs, which structure should you use? Right? And what is the threshold that you need to set? And what is the expected payoff? Let me say it again. You have like 5 cases, 5 different actions with different cause and effect. Okay? And I want you to use the simulator, right? Okay? To determine which drug do you want to use? Which action do you want to take? And if you take that action, what is the threshold? And what is the corresponding expected payoff? Okay? Make it as a team exercise. I'll give you like 5 minutes. Okay? Be careful though. When you do the adjustment here, you need to add the reduced risk with the cost. Okay, so don't forget to do that. You need to write it down, right? 1, 2, 3, 4, 5, right? So you can do the comparison, right? So you should have like five expected value and also five optimal threshold, right? Corresponding to each case. So anyone finished? You need to write down, otherwise you cannot compare, right? Because the simulator like only. Any question? Or should have been done, right? Get it? You finished? Or you do not know what to do? Do you know how to do the setting? How to adjust the slide bar? Have an idea of? Then you just like, as I say, according to the this specification, you can adjust the. Actually, you only need to adjust this two slide bar, right? Okay. And after your adjustment, you should see the expected value and the optimal threshold, isn't it? Right. The tricky thing is that don't forget to add the cost here, right? Okay, that's the thing. So at the end, you should have 5 expected value and 5 cutoff threshold. And you should write it down, and according to that, there will be a best, right? A best way to do it, right? Out of the 5, what is the best way to do it? Anyone got the answer yet? Alright? How about the rest of the team? Raise your hand, you need more time? Anyone need more time? Okay. So we don't have too much time left. Let's see your answer, right? So which team has answer already? No? So what is the problem? What is the problem? You you know how to do the adjustment according to this, right? This is the cost, right? So cost go to here, right? The first case is say that $5, right? So it's 5, okay? And the effect is it will reduce to like 70, right? And 70 plus the cost is 75. So the best expected payoff for the first thing is like 217, isn't it? So, and then you need to repeat this process for like 5 times and pick the best one. Any question? You get the answer yet?
I think so.
Sorry?
Yes. Yes.
So which drug do you choose? The first one, the second one, third one? The fourth? The fourth one? Okay. Anyone have the different answer? This could be right, okay? And I'm just questioning. You do know how to do the adjustment, right? Anyone who still do not know how to do the adjustment, please raise your hand. This is important, right? Because I don't need you to write any program, right? You just like put in the case and choose the best one, right? Okay. Do you know what to do it? You get the answer? The same, right? It's the fourth one, huh? The fourth one, okay. How about this team? The same. You are the same. And which team is that team? Okay, so everyone get the same answer, right? It looks like the fourth action is the best action to take, right? Okay. Actually, instead of doing, because this simulator just do the one action at a time, right? So actually, at the end of the notebook, I write a code that like plot the curve for 5 actions in the same chart. Okay, so it's easier to compare them, right? It's easier to compare. So if you want to do that, you need to like enter all of the matrix, define all of the matrix, and then do some coding, right? And this chart is actually interactive chart. So the action that would lead to the best result is actually this blue one, right? Blue one is actually drop 4, right? Isn't it? Okay? So in R, actually, as you can see that I can actually define all of the, right? All of the payoff matrix, and then with that I can like plot the phi curve with this code and then make it interactive, right? So we know that drug 4 is the best drug. Then we can select drug 4, and then its optimum value should appear somewhere at here, right? At 0.43. 46? I think it's 443. Okay. According to my calculation. Okay. Let's do it here. The fourth drug is like $20.40, right? So here we should set it to like $20 and minus 60, right? So it's 47 actually, okay? 0.43, okay? Now, let's take a look at this. Let's take a look at this chart first. Now, there's an interesting thing that you can observe, right? This point never changed, right? Okay? What does it mean? I think it changed, the curve changed, but the endpoint never changed. What does it mean? When you set the cutoff to 1.0, it means that you take no action at all, right? So whatever the cause and effect is, right? If you do not take action at all, it's always, right? It's always like the risk. You are accepting the risk that comes with the complication, right? And doing nothing, right? So if you do nothing, then your analysis will not help you at all. This is the third thing that we need to learn, right? Okay? Okay, this is the first important thing that we need to learn. The second thing we learn is that when you do the analysis, it helps you choose the solution, right? Now you have 5 solutions. You can choose the best. Okay? The first thing is to help you choose the solution. Okay? And then the second thing is that it helps you choose the subject to apply that solution. Right? In this case, it's like more than 47. Okay? If the predicted probability of poor care is higher than 0.43, then I would apply the action. Okay? That would reduce my cost from here. It's like 252,000 down to like 207,000. Okay? So this analytic process, right, is kind of lengthy, as I say, right? It data, model, predict. But if you stop here, then it will do no good to you at all. Okay? You need to do some assumption, simulation, decision, and action, and take action, right? And in this process, it will help you if you do it right, right? It can help you choose the alternative solution and identify the optimum threshold of action, right? Identify the target subject to apply the action, and also estimate the expected payoff. Okay? And that is the benefit of business analytics, right? And that is why we bother to make model, do prediction, whatsoever. Okay? Okay. And the code itself is actually not difficult, right? It's just one function code to make the model, one function code to make a prediction, right? And then you need to do some assumption, and this is the tricky part, right? Okay, so you need to because assumption, so you're not sure, right? So you want to have some flexibility about the assumption. That's why we do the simulation and do the manipulation, right? And then with that, if you do it right, it only takes like 4-5 lines of code to calculate the expected result according to the assumption and all of the possible cutoff value, right? And then you can visualize the result and then make your optimal decision. Okay? And that's what we want to cover today, right? And it should give you a very good, I should not say very good, it should give you a complete idea about what is business analytics and why we want to do that. Okay? When you do it right, it helps you to choose solution. It helps you to choose the subject to apply the solution. It helps you to evaluate the cost effectiveness when you apply the selected solution to the selected subject, right? And which is impossible if you do not do the analysis. And the analysis code itself usually is not complicated. The important thing is you need to have a holistic idea that link each of these steps, right? One after the other. And that is programming, right? And that is programming, right? That's why we learn programming. When you learn programming, you actually can like write a page of a program, then you too can do this analysis very, very sophisticatedly. Okay? Okay, so this is the ideal, and as I say, this is a simplified case to Tafang, because in Tafang will be a little bit more complicated, right? In the case of Tafang, we will need to predict the purchase probability, predict the expected return, right? And the assumption would depends on the instrument that you use, right? You can do a promotion, advertisement, you can send out coupon, whatever, okay? So it's a little bit more complicated, but don't worry about that. In the next two class, I will like bring you to the context of Tafang and do that with you, like step by step, okay? And one thing that worries me is that basically if you take a look at this schedule, there's only 3 days left. Okay. after I actually I would spend next week to do how to do data splitting and modeling, and then spend a week for assumption and simulation. But I will teach you everything on the context of Tafang, but you only have 3 days left to your, because we like pull forward the final presentation, right? So I will try to give you a simpler mission, right? So it will become too complicated, but it's still very challenging because you don't really have too much time to prepare.
Professor, will the final presentation also be a contest?
So, yes, it's also a contest, and this time I already get the budget for prize. So okay, we'll have prize. Okay.
For final presentation, we will record like midterm exam, or we will present in class.
Yes, you actually we do the same format as in the midterm. You do the video, record your video, and then you don't do it like, because if you record recording, it will be like easier to prepare and easier to do division of labor, right? Okay.
And for the slide or the lesson, can you provide us with for next week? Like, I think that we can, based on the slide and your coding, we can do our final exam, because 3 days kind of very risky to.
Of course, I will give you the sample code, so you don't need to do everything from scratch. Actually, I think you don't need to do the presentation and simulation code. Again, I will give you some simulation tool like today, right? So you can like simply by using the tool to do your presentation instead of writing code line by line. Okay, I'll try to do it that way. Okay, okay. So I'll give you sample code. I'll give you simulator like today. Okay, so you can like using the simulator to do your final presentation. Okay. Question? Okay, we already run out of time, right? It's already 10 after 12. Sorry about that. But this is a very important class this week, right? Because that is the spirit of business analytics end to end. Okay? Okay, so that's all for today. I'll see you next week. Try to be punctual, right? Because if you are late, I believe it's difficult for you to catch up of what we have already covered, right? So make it very difficult to catch up if you're late. So try to be punctual next week and the week after, because we really need more time to like give you a better idea about how to do it in the more complicated business context. Okay? Remember to turn off your desktop computer, okay?